Julio, hi guys, my name is Digara. The journey is 8Z204. In the last video, we ended on beginning of the long journey. Cool. First module that we go into after that is create Azure uh, app service web apps. Then the first module that we're gonna tackle is explore Azure app service nodes. So that's explore Azure App Service essentially. And under that, we have a subtopic that says examine Azure App Service. So I would say the Azure App Service is meant for web applications, the REST APIs, and mobile backends. Supports .NET, .NET Core, Java, Ruby, Node.js, PHP, and Python. This can run on both Windows and Linux uh, environments. Then it supports auto scaling, so that's scale in, scale out type of functionality. Uh, then there I'm explaining what scale out or scale in means. That's the increase or decrease instances. So if let's say for example you have one API, so if we run that same API in parallel, so having that API as two instances, that will be scale out, scale in. So think of it in. Let me try to do this. Uh, Cool. So I have an API here, which is API one, right? Then if I'm doing what do you call scale out, what would happen is I have another instance here of API one. So this will be API one B essentially, but it will be the same clone or same instance, same code base, same setup as this particular API one. So there's a scale, what do you call scale out. So when we scale in, what then happens is we actually uh, doing this. We're removing instances from that particular thing. So we're reducing the number of the same instance. So this is an instance. So that's scale, what do you call? That's scale in, scale out. Scale up, scale down means currently, let's say, for example, here, this box here represents the amount of compute resources. So your CPU, your memory. This is what do you call? This is an instance that we have that now we want to do a scale up. So a scale up essentially what would mean is we would be doing this to it, right? Uh, this will fall away because we are scaling this particular instance up. So this will be that will be API one. And remember what I said, this box represents the resources, compute resources. So you can see by virtue of looking at this that we have more, let's say, compute resources, we have more memory usage and all of those type of compute resources. So that is a scaled up type of approach. Scale down type of approach, what would be typically happening is we'll be going through and taking some of the resources selected up there, deleting them, and effectively making this API a lot, what do you call, a lot smaller. This is more or less scaled down type of implementation. Cool. Maybe I came up with that analogy to explain it. That was fun. Then Azure App Services support CI/CD out of the box for Azure DevOps, GitHub, Bitbucket, FTP, local Git repository using auto syncing code and future changes. Supports deployment slots for testing code between actually promoting to target environment. What deployment slots for testing code before actually promoting to target environments. Okay, cool. So what happens is in that particular case is that we have a situation where we have API one running in production, right? So this API one running in production, API one API one running in production, but then we have some sort of what do you call code changes that are coming in, right? Uh, uh, code change. So we have some sort of code changes coming in. Wasting time with this thing. So this is, look at this as code changes. Code changes needs to be deployed into production, right? So this is prod. Prod. So before we deploy to production, typically what we need to do is test out this thing in an environment that looks like prod. So more or less the same resources, more or less same configurations and all of that. So we want to test out this thing before making it publicly accessible, just to pick up, last minute issues that we might have missed and all of that. So instead of deploying directly to this prod instance, Azure has this thing called a deployment slot, right? A deployment slot will have uh, API1, API1 with uh, changes, with code changes, essentially, right? Yeah, better. So API1, it will have API1 with code changes, and this environment would be called what do you call staging, right? Staging. So instead of this code going there directly, what would happen is our code first goes into this staging environment. We do testing, we do transfer. It allows you to transfer certain portions of the traffic configurably to the staging environment. So you could set it to say take 10% of traffic coming into our website, take it to the staging environment just to test it out. You can use staging environments to test out pre-release features. So features that are not publicly accessible, you can release them using this type of environment. Staging environments. Cool. Once you are happy with that, what you basically do is you swap out this one with this environment, right? So when you do the swap out, because this thing is already running, what this thing does in configuration is changes the it changes the traffic to this particular instance, sets this instance as now your prod instance, and this one becomes your staging. So if, let's say, for example, you do the swap and this particular staging is now your prod, but your prod becomes bugging when this particular part is becoming prod, what you could do is swap out the stages again, then use this API instance as your prod and discard that or fix that however you need to. Cool. That is us saying deployment slots. Then we have app services on Linux. Support custom Linux containers when application runtime is not supported in built-in images. So you can create custom Linux containers when the runtime of your application is not supported in the built-in image. So there's built-in images for Linux that you can run on. If you can't use any of those, you have the free will to actually run your app service on a custom container, essentially image. Then Linux app services support .NET Core, Node.js, Java, 8 and 11, PHP, Python, and Ruby. Cool. This does not support .NET, by the way. If you look at it compared to what app services support, is the .NET part. So .NET part is not supported in Linux. Cool. Then to check the list of supported languages and versions, use the following command on the Cloud Shell. So if you wanted to check which runtimes actually supported on that, I'm gonna do that actually. Which one should I use? PowerShell. Try PowerShell. So I have PowerShell open there, and I'm gonna check if I have the AZ module installed. Cool, I have it installed. So it says AZ web app list runtime list runtimes. Cool. We are hoping to get a list of runtimes that are supported. Typo. Web. Web. So web app misspell. What did I misspell? List, web list. Right? Maybe I need to do that. Okay. So maybe it wants me to say in next page. Yep. Okay, cool. So the actual command is this, guys, not what we have on the notes. So based on our practicals, we'll have to just make adjustments to that. And we just pick the text. Cool. So that's the correct command. So if you look at that, it runs .NET Core 2.1, .NET Core 3, .NET 5, 6, Node 14, Node 12, Node 10, Java 8, Java 11, Tomcat 8, 9, 9 as well, JBoss 7, PHP 7, PHP 8, Python 3.8, 3.7, 3.9, Ruby 2.7, 2.8. Cool. So I'd like to say that and say Windows. See how different it is. Ah, that doesn't work. Why? Yeah. I think I misspelled their own shit. Yep. Okay, cool. That doesn't work for Windows. I thought it would work. Yep, we're getting issues. Fine. Then the limitations of an app service, limitations of Azure app services. So app service on Linux not supported on shared pricing tier. So you can use a shared pricing tier on this. So there's a couple of pricing tiers that you can use on your app services. I'm assuming we'll go through them later on. But one of the limitations is that you can use a shared app service plan when you want to run your app service on Linux. Cannot mix Linux and Windows app services in the same app service plan. So app service plan, remember, it specifies the resources that your app service will run on. So app service plan, think of it as a container of a bunch of app services. You can contain a bunch of app services, including functions in that. So with what do you call defining an app service plan, you technically set up the runtime environment and all of that for that. So now, if you want to mix a Linux and Windows, that means your app service plan must be running on two OS operating systems, which is technically impossible for a VM to run on both services unless if you install, partitions and you do wanky things. It's possible in that way, but Azure does not support that type of functionality. Then you could not mix Linux and Windows app services in the same resource group prior to 21 January 2021. Then now looking at the day that we are on, I'm recording this on 02 March 2022. That means technically speaking, you should be able to mix Linux and Windows app services in the same resource group. And then can only see working features on the Azure portal. Features activated on the portal as they get enabled. So yeah, what they're saying is there's some features that are on pre-release, features that are on preview mode. So you cannot see these features what you call on the Azure portal. So Azure portal, I do not want to open my portal yet because of security. Azure portal, Azure because of security thingy that needs to go in. I need to make sure that I'm not showing you confidential information from my company and all of that. So cool. This is more or less how an Azure portal looks like. So they are talking about this thing when you click on app services. Let me see. App service is your portal. There they are creating one, but then some of the features essentially you won't be able to see them on the portal itself. So that means, they are on pre-release, preview, or whatever the case might be. Hence, that listed as a limitation. Earlier, we are going into another module called Examine Azure App Service Plan. So under this module, what we essentially have is app services. App service runs on app service plan. That's a requirement. You need to have an app service plan to be able to run an app service. So at most, no. An app service has to have an app service plan to some degree. Then app service plan defines the compute resources can be shared by multiple app services. Azure functions have the option to run on app service plan. Cool. So what I mentioned here, essentially, there's a better way to do this shit. I think I could be using one of the design systems like Draw.io or anything like that because it has these icons out of the box. I'll try to do that for the next video actually. So what you have here is think of this as an app service plan, which is a container, right? That's what I said earlier on. This is a container for a bunch of app services, right? These blocks that you have here are app services, and also you can have Azure functions running on app services. So remember, Azure functions are effectively give you the serverless computing type of functionality, but you have an option to configure them on the thing. You have the ability to configure them to run on an app service plan. So they will use the resources specified for the app service plan, and there's a bunch of benefits that comes with doing that, right? Bunch of benefits uh, include abilities like or things like um, come on. The security of the application, you can set it a bit more better. The price plan around that, you can have some predictability when using an app service plan versus using serverless function itself. All of those, there's a bunch of benefits. We'll go through them as we go through the content. But what I was showing you here is app service plan versus what you can run in the app service plan. So there can be a bunch of APIs, there can be a bunch of functions. What we were saying earlier on is that app service API one, which is an app service, cannot run on Linux while this one runs on Windows, simply because what we just found out is that this thing here actually gives us a specification for compute resources and all of that. Julio. That's that. Cannot. Okay, that's the old part there. Okay, that's what we were explaining. The app service plan is created in a region where app services are going to run at. So because remember what we said, app service plan. So think of an app service plan like a computer of some sort, a pseudo computer. It's not a computer, but it's a specification of resources. So when you specify this thing, you actually give an app service plan a region. So when you put a resource in a region, in Azure terms, effectively you are telling Azure which data centers, availability zones, and all of that it should be using to actually run your application. So that's what they mean that they say that app service plan must contain applications or app services that are going to run in the region specified in the app service plan. So if you put this thing in North Europe, technically speaking, your app services should be running in North Europe because the compute is there. Otherwise, it's a mix and match. Uh, App service plan defines region, number of VM instances, VM instance size, pricing tier. As I mentioned, there's a couple of pricing tiers. There's a free, there's a shared, basic, standard, premium, premium V2, premium V3, and isolated. Isolated is where you don't want to share this particular compute resources with other clients. So technically, you don't want you want your own kind of setup, own network infrastructure, and all of that set up in Azure. That does not mix with any of the customers that we have on the other tiers. So free tier bunch of limitations here and there. Shared, you actually share the compute, the resources can be taken down and all of that. You have basic, which gives you basic features. You can read up on that if you wanted to go deeper. So I see the section here explains that. So with pricing tier, the shared compute, we have free and shared run on allocated quotas in shared resource pools and cannot scale out. So with shared compute, meaning on free tier or on shared what do you call tiers, you only run on allocated compute. So Azure will tell you that this is the quota that you can use for the month or the week or the day. If you exceed your quota, then you basically cannot run for the remainder of the day. Then it does not enable scaling. So imagine scaling on a limited amount of resources. So that's what that thing is. Then under the tier that is specified for dedicated compute, we say app services run on dedicated Azure VMs. Only app services running in the same app service plan share compute resources. Higher tier means more VM instances to isolate to scale out to maximum. So that last part or that last sentence is saying if you go for a dedicated compute type of setup, they have more or the higher the pricing tier, the more instances you can run. And once you do that, once you can run more instances, that means you can scale out more effectively. Then uh, they say on dedicated, your app services are running in the same app service plan. They are not sharing what you call the Azure VM. There's Azure VM is dedicated to that particular app service plan. Then every application or every app service that is in the app service plan then shares the compute resources specified by the app service plan and the dedicated Azure VM. And then in isolated, you have maximum scale out capabilities, runs on dedicated Azure VMs on dedicated Azure networks, right? So that's what I was saying there. Your network and compute is totally isolated because you are running on dedicated Azure what do you call VMs and network. Then consumption plan, this is only available for function apps, dynamically scale functions depending on workloads. So consumption plan, you pay for what you use. You don't pay for a set amount of resources. That's what the consumption plan is, and it works well mostly for Azure functions. Though it has other shortfalls with regards to what happens if I use a lot, what happens if I'm not meeting my targets. Cool. Then here I have a note to say app services on free and shared pricing tiers share resources with other customers' app services intended for development and testing purposes and not for production. So according to Microsoft, you shouldn't be using this free and shared tier for production instances because of a bunch of limitations. So remember, it's running on a quota basis, so it can go down at any particular time. Because this compute is shared between customers, there's a concept of bidding for what do you call the compute. So if someone bids more than you have a situation where your compute is taken away and given back as and when Microsoft decides. How does my app run on scale and scale? Okay. Free and shared app services are allocated CPU minutes on shared VMs and cannot scale out. Right? This is what I meant. Shared and free, you have allocated quotas on the CPU minutes. Essentially, app services run on VM instances configured to the app service plan, right? As I mentioned, app service plan specifies resources. So app services run on the VM that's specified there. And you can already see why you can't support Linux and Windows in the same app service plan because you have a VM running underneath the app service plan. So that already tells you there's an OS configured of some sort. If deployment slots are enabled, all deployment slots run on the same VM instance configured on the app service plan, right? What does that mean? Remember what I was saying with deployment slot where you have staging and production. So for the same API, you have staging and production and all of that. So what they are saying here is that that staging and uh, production instance are actually running on the same what you call VM instance that is configured on the app service plan. So they are not separate in terms of the VM instance they use the same VM instance and they share resources essentially. If you enable diagnostic logs, perform backups or run web jobs, they also use CPU cycles and memory on this VM. So all your diagnostic logs, your performance, your backups that you perform, and web jobs that you run effectively uses compute power that you have specified on your VM instance. That's what that says. App service plan in uh, App service plan is the scale unit for the app services apps. So the app services apps that run on it. When an app service plan is configured to scale, all the app um, all the apps scale according to the configuration. If app service plan has 5 VM instances, all app services in the app service plan run on all 5 instances. Okay, cool. That Microsoft didn't do a good job explaining, but what I'll do here is I'll expand this. So now this is our app service plan. It has a bunch of APIs in it, right? Then what they are saying on that statement is that an app service plan is a scale unit. What does it mean to be a scale unit? It means that if we wanted to scale, based on the app service plan, what would happen is would configure the maximum number of instances that our app service plan can run on. So once we scale, this is typically what would happen. Select all of these things, have them. This is app service plan, the original one. It will create another instance of it, which then looks something like that. If you want to scale out again, it will create another set of it, so forth and so forth and so forth. When we scale down, it then goes back to removing the other instances. So that's what it means. So you can't now run 2 of these or 3 of these or whatever by scaling the app service plan. When you scale an app service plan, you're scaling everything in the app service plan itself. If you see limitations there, then that's good. That means you are getting on. We're going with cloud computing. What if my app needs more capabilities or features? Okay, cool. So if your app or needs more capabilities or features, what you can do is change the app service plan pricing tier. So that is effectively scaling up or scaling down. So remember, we have free, shared, basic, standard, premium V2, V3, isolated, and all of that. So as you go up the pricing tier, you get more features. So chances are you need to go up in the pricing tier. That's what they say there. Move app into separate app service plan. So cool. If you need more capabilities, and one of the other options is you don't want to actually pay for everything that is in the app service plan, what you could effectively do is take one of your apps out of that service plan into its own separate app service plan and scale that out. So cool. Uh, I'll come back with my paint diagram. What they mean there is you have an app service plan there. What you need is this extra features that you need for API 10. So what you then do is you create another app service plan there. App serve plan 2, right? This is another app service plan that then takes out API 10 and places it into the new app service plan, right? Then this thing could be running on tier. We'll say the tier is standard. But for some reason, we want to have some other feature that is premium, and we only need the premium tier for this particular API. We can say tier premium. I forget that. Premium. So put the tier as premium, and of course, we can choose the minimal compute, minimal storage if necessary, whatever the case might be. So in that way, what happens is we can scale up this app service plan independently of this particular app service plan. And that's what they effectively mean there. When they say move it into that, sharing app service plan can save you money, but can also be costly when load is high and features on upper pricing tier are only required for one app. Yeah. That's to support that statement that we have there. To say that, you know, cost can be very high if you are scaling the app service plan that has a bunch of items compared to, scaling an app service plan that only has one. Isolate apps into separate app service plan when to actually separate applications into separate app service plan. When the app itself, the one app, so for example, what we did there, when API 10 becomes very resource intensive, so it uses a lot of memory, a lot of CPU independently, then you'd want to put it in its own app service plan. Then we have another one that says the app needs resources in different geographical regions. So Microsoft has this thing of having, different resources in different regional regions essentially. So you have features that are only available in a specific region and all of that. So if you need those region specific resources and features, you could put an app service plan in that region and put your app that requires those features in that particular app service plan. Then you can separate also when you want to scale apps separately from the apps in the existing plan, app service plan. So that's what we were talking about, moving it into 10 because we wanted a feature for that particular app service itself. Cool. Then there's another module that we need to go into. I'm not sure where I am on my notes. Just, yeah. Okay, looks like we're far off. This video is dragging. I thought it was going to end around 15 minutes or so. Cool. So now here we're dealing with deploying, what do you call we are dealing with deploy to app services. So automated deployments are supported for Azure DevOps, GitHub, Bitbucket. I think we mentioned a couple more up there, but theirs is limited. Let me just see that. Okay, yeah, cool. So that Bitbucket FTP local repo. That's that. Cool. Then what you could do with DevOps, GitHub, and Bitbucket is you can do manual deployments. Manual deployments, Git provide a repository URL to app service. When changes are pushed, a deployment is automatically triggered. Cool. So what happens here is you associate your app service with a Git repository. As soon as you push a change into that specified branch or whatever the case might be, app services automatically picks up those changes and deploys them into your application. Then you can do it through a CLI command where you run AZ web app command to create a new app service web app for you when one does not exist already. So AZ web app command uploads a file or bunch of files or your application essentially into an app service. You specify the name there. If the app service does not exist, it automatically creates the app service for you. If it already exists, it just uploads the files and makes the changes accordingly. Then you can also use a technique called zip deploy. Zip deploy can be done with any command line or console application that supports curl or similar to HTTP that support curl, which is similar to HTTP utilities to send app zip files to app service. That's a complicated statement, doesn't make sense. But then what happens is you need to transport your zip file into the app service using an HTTP connection type of implementation, protocol. FTP or FTPS, that's the secured version. This is the unsecured version supported as the traditional way of pushing code to many hosting environments. Okay, it is recommended to use deployment slots when deploying new production build. Deployment slots supported for standard tier from standard tier. This has a bunch of benefits, including downtime. As I mentioned, when it does the swap between staging and production, it makes things a lot easier. It doesn't have, a lot of downtime or anything like that. Then explore authentication and authorization in app service. So with an app service, you provide a built-in authentication and authorization from minimal no code. So technically speaking, you can configure authentication and authorization with minimal code because of a bunch of options that you have from what do you call, from Microsoft. Then here we say why use built-in authentication, and then here we have no a requirement to use app service. Oh, cool. So it is not a requirement to actually use an app service authentication and authorization, the built-in one. You can use in any other authentication method if you wanted to. You can implement your own. Built-in authentication and authorization saves you time. This is actually where the why you should do it starts. Built-in authentication and authorization saves you time and money by using federated identity providers. So you could use, let's say, your Twitter, your Facebook, your Google to do federated identity authentication to application without any writing any code to cater for logging in users and all of that. So that's authentication and authorization using federated identity providers. Building capabilities do not require any language. So there's an you can use that using the relevant SDK, security expertise, or any code change. So building capabilities, you can actually configure them without using a programming language, an SDK, a security, or you don't need the security expertise or to make any code changes. Basically, you can enable building capabilities, what do you call, uh, through configurations on the portal or on the Azure CLI or PowerShell or whatever the case might be. So you don't need to actually make a code change to your application. But that's the gist of the message then. Can integrate with multiple providers such as Google, Twitter, and Facebook. That's what I was mentioning. So Microsoft supports that, and we will delve deep into those when we look at the authentication platform. Then the identity providers, the default identity providers that we have in web services is Facebook, Google, Twitter, Microsoft Identity Platform, which will delve deeper and understand at a later stage. Can configure any of the above without limits. So you can mix and match whatever you wanted. So your application could take both Facebook and Google, or all three of them, all four of them. It's up to you how you wanted to do things. How it works. Authentication and authorization modules runs in the same sandbox as the application code, right? Authentication and authorization module runs in the same sandbox as the application code. So we have a module that runs just before your application in the same application code, I mean, in the same sandbox. So in the same environment, you have an authentication and authorization module running on top of your application code. That's how it enables you to not do any code changes in application. All HTTP requests pass through the module before the handlers in the application code. So that authentication and authorization modules act as a barrier between your application and end users. So when an end user passes a request to your application, what happens is the authentication and authorization module assesses that what you call request, talks to a federated identity provider, whatever the case might be, gets the relevant token. If the token is there, it validates the token and all of that. If the user is authenticated and authorized, it then passes the request to your application code, and your application code now executes the relevant business logic. Then the module, the authentication and authorization module, uh, put that there. It handles user authentication with specific provider. So that's those providers that you have there. Validates, stores, and refreshes tokens. So if a token has expired and there's a refresh token, it can do what you call refresh tokens for the users and all of that. It validates the tokens, as I said. It stores the tokens as well. So you don't need to store the tokens to manage the sessions yourself. Manage the authenticated session. So basically, it checks the authenticated session, routes it accordingly, and all of that. Then it injects identity information into request header. So basically, if let's say, for example, our application needs username, email address, or whatever the case might be, we can configure the authentication and authorization module to pass us the specific information on request headers. Then when we process them in our application, we just read the request headers and process accordingly. Module configured using app settings. So you can configure this thing using app settings. And I'd like to actually add a note somewhere and say configure authorization and authentication module. So I'd like to do a practical on that. Then NB in Linux, the authentication and authorization module runs in separate containers because it does not run in process. So .NET applications, .NET Core applications are running in process, most of them. So now because in Linux we don't have this functionality supported of in process, therefore the authorization and authentication module actually runs in a separate container. That's what it's saying there. The authentication flows depend on signing in user, the provider's DCK. I don't know what that means. I think here we wanted to say SDK. Yeah. So it depends on the signing in. It depends on signing in using a provider's SDK or not. So if your authentication is using the provider, so a Google SDK, or it's not using it, the flow becomes different. So without the provider SDK, so without the Google's SDK to do authentication, we have a server flow, or it's called server directed flow. Application delegates sign into app service, browser app presents login page and sends the server to manage the sign-in process. Right? So what happens here? Okay, let's read with provider. With provider, it says client flow or client direct flow. Client and client auth user to provide manually, then send the token to app service for validation. Applies to REST API, Azure function, JavaScript, browser clients, and native mobile apps. So cool. What happens here is, well, the gist of the message here. Here is the client itself goes to the provider, gets a token, then takes the token and sends it to what you call the app service. This could be done using whatever front-end language or whatever coding language you use to get what you call the token from the provider using the SDK, right? Then without the SDK, what happens is a user just sends a request to our app service. Our app service detects that this user is not authenticated. It brings up a login screen with federated identities. Then the user selects Google. Once it selects Google, our app service goes to Google, gets the token and all of that, and logs in the user effectively. So that's the difference between without a provider. With a provider, the client goes to Google himself or herself. Without a provider, we go to Google through the app service. Cool. Then here there's a table that shows the steps of authentication flow. Then we have the step is signing user, redirect the user to the auth. Then we put a provider there. So it will be .auth login /Google, .net login /Facebook, or whatever the case is. Post authentication. Then after the authentication has happened in the provider side of things, we need to provide it with what do you call a redirect URL. So the redirect URL will be .auth /login provider, which could be Facebook or whatever / the callback. That's the URL. Then establish authenticated session. App service adds authentication cookie to response. So once we do that and the response gets to the user, there's a cookie that gets stored in the user's browser. And that is what we essentially use to do the communication. Then server authenticated content. Client includes authenticated cookie in subsequent request automatically handled by browser. So as I mentioned, because the cookie is not stored in the browser knows how to send the cookie for each request that we have to our application. Julio, for client browsers, app service can automatically direct all unauthenticated users to that. You can also present users with one or more providers, like links to sign in your apps using their provider of choice. So that's what I was explaining there. Authorization behavior can configure app service in portal with several behaviors when incoming request is not authenticated. Allow unauthorized requests, uh, unauthorized requests, different from authorization and authentication traffic to application code. This also enables you to present multiple sign-in providers to your users for authenticated requests. Okay, cool. For authenticated requests, app service passes authentication information in the HTTP header. Remember what you were talking about, or the checking cookies and all of that. So first option that you have there is you can allow an authorized request to go into your application, and that's where now you do displaying of the different providers and all that. Alternatively, you can require authentication. So when you require authentication, let me do this. When you require authentication, what then happens is it rejects all unauthenticated traffic to your application, rejects calls. Uh, Rejected calls can be redirected to provider. If not configured for provider, can return 401 unauthorized or 403 for all other requests. So 401 unauthorized when you don't have permissions and all of that. 403, you don't even know who you are. Essentially, that's what it means. So with require authentication, essentially every call is is rejected until it's authenticated. So you can configure it on the portal to say take this call to the provider and allow the user to log in. If you have not configured that, your API or your web app will actually return 401 and 403 what do you call uh, responses. And such restrictions can have an impact on accessing publicly accessible links like home pages and many spa applications. So cool. When you say, for example, when you have this required authentication set up, you can't get to a page that needs to redirect you to, a login provider or whatever. If you are using a spa application, you can't see the error message or whatever. It will just throw a 401 and you won't be able to see anything. So those are some of the things to take into consideration. This video is dragging for too long, so I'm just gonna cut it here. And when we resume, we'll start with the discover app service networking features. Cool.